We'll take a look at some of the examples from standard atomic notation, focusing especially on ions and isotopes. So our first example here is the only one that's not an ion or an isotope, but was a tricky one because the total number of neutrons was 0. So we figure out the number of neutrons from the atomic mass, subtract the atomic number. So the total number of particles in the nucleus, protons and neutrons, subtract protons. And if we end up with a number of 0, that means there's no difference between how many protons there are and how many total particles there are in the nucleus. Or in other words, there are no neutrons. So we need our numbers to be the same. So I'm going to look over here on this version of the periodic table. And we're looking for numbers that are the same for both of our numbers. And hydrogen is the only one that gives us the same number for the atomic number and the atomic mass. So this one would have been hydrogen, which is a 1 and 1. So we have 1 proton, 1 subtract 1 is 0 neutrons, and then our number of electrons is going to be the same, and the element here is hydrogen. Okay, the next couple we'll look at are ions. So I have here Na+, so I know it's an ion. Na, if I look at the periodic table, that is the element sodium. The number of protons always from the atomic number here. So everything that is sodium has 11 protons. The number of neutrons is from the atomic mass, subtract the atomic number. So total number of particles in the nucleus, take away what we know are protons, and we're left with neutrons. So 23 subtract 11 leaves us with 12 neutrons. And then for number of electrons, here I have a charged particle, and my overall charge is plus, or a 1 plus. So that means I need a difference of 1 between my protons and neutrons. So I have 11 positively charged protons. If I have a positive charge overall, I must have more protons than electrons, and by 1. So that means I have 10 electrons. That gives me 1 more proton. So I have 10 electrons here. So 10 electrons will cancel with 10 of those, leaving me with 1 proton there. Okay, the next one is if I'm told that I have a bromine ion, how to figure out the rest. So what I know from there is bromine is the symbol. I'm going to look at the periodic table to figure out for bromine how many protons there are from the atomic number, and then 79.9 is going to round to 80. So 80 and 35 are the two numbers that I have. 80, 35. So the atomic number is the same as the protons. Neutrons is the atomic mass subtract the atomic number. So that's a difference of 45. So 45 neutrons. And electrons here, bromine is in group 7. So it has 7 valence electrons to have a full outer shell and be stable. It needs to gain 1 electron. So originally it would have the same as the proton, so 35, and if it gains 1, it now has 1 more than it had before, and that's going to give it an overall minus charge. It's gaining 1 electron, so it has 1 minus for its charge. Okay, next we're going to take a look at some isotopes. So uranium-236. The 236, so the thing that can change in an isotope, is the mass. So that is the part that we are going to write differently, not from the periodic table. And we'll look up in the periodic table. So uranium is down here. So 92 is its atomic number. And you can see that we have a different atomic mass, but we are looking specifically at the isotope that has a mass of 236. So 92 is the atomic number, so that's the number of protons. 236 minus 92 is 144 neutrons, and unless specified otherwise, it is not an ion, so the number of electrons is the exact same as the protons. And just one note about standard notation. We often actually will not write the atomic number because 92 and U both tell us uranium. So the number of protons, remember, determines what type of element something is. So I can figure out that something is uranium either through its atomic number of 92 or through its symbol of U. Anything that has 92 protons is uranium. Anything that has the symbol U is uranium. So because of that, I will often write the symbol just with the atomic mass. That can change if we have different isotopes because we have a different number of neutrons, and each neutron will impact the mass that we have. So the mass, the atomic mass, we have to write down. We can't just get that from the periodic table. The periodic table gives us a weighted average of all the different isotopes that exist for each element, and we look at that in a specific lesson. But we don't have to write the 92 because anything that's uranium will have 92 protons. We can always look that up in the periodic table. Okay, one last question to try, and this one is not on your practice sheet, but one I wanted to try for isotopes. So 6 protons and 8 neutrons. So to determine the element name and the symbol for the standard notation, is always based on the number of protons. So we're looking for what has 6 for its atomic number, and that is carbon. So I have carbon, I have 6 protons, element carbon, and I'm not given any information, so my assumption is it's an atom and not an ion, which means my number of electrons is also the same. To determine the mass, I'm not going to use my periodic table. I am given the protons and the neutrons, which is what makes up the mass. So I have 6 protons plus 8 neutrons, each with a relative mass of 1. So I have 14 as my mass here. And if I looked at the periodic table, that would have given me 12 and not 14. So this is the isotope carbon 14. Now this only asks for the element name, not to specify an isotope or an ion. This is just practicing how we recognize that it is not the most commonly found isotope of an element and which one it happens to be.